All right, we are now on target 2B, and this is day 1. And we're going to be working on determining congruence. So for your learning goals for this day, I can describe the transformation that maps the pre-image to the image, so we're going to get more practice with that. I can determine the transformations that could result in an image being determined from the pre-image. And I can determine the value of a variable that would maintain congruence between two figures. So this right here, this is from last unit. You're going to be doing the same types of things. So on the plus side, you get a little more practice with that. On the downside, if you weren't too keen on that, guess what? We get to do it all over again. All right, so now just remember, a translation is an image that is slid in a certain direction or directions. So it can go left or right, can go up or down, or it can do both. Rotation is an image that is turned around a point, and a reflection is an image flipped over a line. That's the easiest way to put it. All right, so let's look at our first example. We have two triangles here, ABC and DEF. And we want to describe the transformation that maps the pre-image of triangle ABC to the image of triangle DEF. So if we look, this has been rotated 100 degrees, and specifically it's been rotated 100 degrees about this point right here. So the way to think of that is, if I drew basically a line. So imagine that I've got this on a stick or something, and I took the stick and I spun it up to here. All right, so this is me holding the stick, and I turned around to look at someone behind me. It would be exactly the same image as before, just rotated. So if I could take this and spin it back this way, it would fit directly on top of here. So all that has happened is it's been rotated 180 degrees, because remember, going all the way around back to the original starting point would be 360 degrees. So this is half that. So right here, going from here to here would be 90 degrees. This is 180. If we were starting here, so this is our starting point. If we were starting here and we went all the way around, that would be 270 degrees, and of course this would be 360 degrees. Second example. So which rigid transformation could map the pre-image to the image? Now, we have a couple of different options here. So if we looked, and this is our pre-image and this is our image, they're congruent figures. I could say, well, it's been rotated, so I could say I've actually spun it, so 180 degrees clockwise or counterclockwise. I could go either direction, and that about this point right here, and that would give me the same image. But I could also say that it's been reflected, oops, go back. I could also say that it was reflected over this line. So either one of those work. If you want bonus points, go ahead and put them both, unless it asks you for all the possible transformations. This didn't, but if it asks you for all possible transformations, then you would have to put both. In our final example, determine the value of y that maintains, meaning it keeps the congruence between the two figures. Now remember, if two figures are congruent, then all of their sides have the same measure. So that means that if this is 3 centimeters, then this side is also 3 centimeters. If this side is 6 centimeters, then this one is 6 centimeters. And if this one's 4, then this one has to be 4. What we don't know is we're trying to find the value of y, so this right here. So what's our corresponding part to this? And that would be the 21 centimeters. So when we say corresponding, it means from one image to the other, so not on the same image. So we're going to take this 4y minus 7 and this 21, and since they should be equal in length, we can set them equal to one another. And then just solve like you would for one variable. Add 7 to both sides to get 4y equals 28. Since it's 4 times y, we do the opposite, which would be division. So divide both sides by 4, and you get y equals 7 centimeters. Okay? And actually, we shouldn't have that on there, because all it did was ask for the value of y. Now, if it actually asked for the value of the side, well, we know it's 21 centimeters. So this part shouldn't be here. The value of y is 7. The entire thing is 21 centimeters. And you can go back and check that and say, okay, is 4 times 7 minus 7. Does that equal 21? Well, 4 times 7 is 28, minus 7 is 21. Yes, because 28 minus 7 is 21. So that's how you know you're right. I strongly suggest that you get into the habit of doing that if you have time left on a quiz or a test. So that's all for this for day 1 of this target. Look for a little bit more complex problems tomorrow.